Welcome to all. Today question 37. See, once again master question. Last class was master question covering all types of triangles. That is right angle triangle, isosceles triangle and triangle in general. Rectangle is not a problem. Today, next part. See, covering circle, here circle, semicircle, see, two are there. And quadrant of a circle, two are there. And including concept when there is a cutout. Cutout means some part area is removed. See here, cutout. You can make over a sketch on here. See, empty here. This is all hatched. That is, this is the removed portion. So question is, find moment of inertia about center of the axis, all dimensions in millimeter. Now, I will tell one thing. If you go in a systematic order, easy to difficult, then first rectangle and triangle, rectangle and semicircle, rectangle and circle, then triangle and semicircle, rectangle and what? Quadrant. That way you can do. That all will come later, simple questions. But I feel it is always better to consider a master question, so that people who go through this one, they will just laugh at those questions. See, those questions, you can just laugh. Laugh means what? Hi, how easy it is that way. Light, tangential, okay, that's no problem. Therefore, see, this is the question here. Now see, remember, this is the removed part. By sketch only you can make out. Now, 1 minute. Space problem, I wrote smaller. Suppose the laptop you can see it. Suppose you cannot see, I will tell you, see, 140, 110, 150, 95, 115, 60, 25, 35 and 40. This is 40. Means what? See here. This is, see, correct here. This is a semicircle. You can make a note here. Semicircle of radius 150. See, radius 150. Be very careful. Therefore, later I will write not radius. I always want diameter. So, dia equal to radius 150 means diameter is 300. Because we always solve in terms of what? Diameter. Okay, then. Therefore, I will tell now only. See, diameter is 300. See, this full is 300. And diameter 300 means this is radius. See, 150. So, now this 300 is clear, 150 is clear. I will put a dot there, which are cleared for you. Then, this 110 given in the question. Then, this is quadrant of a circle of radius 140. Diameter you cannot see. If radius is 140, I wrote there, diameter is 280. Because you are solving in terms of diameter. Therefore, this is 140. See, this is 140. When this 140 also clear, 110 clear. When this is 140, this is 110. This from here to here will be 250. Actually, that 250 is also vertical height of the rectangle. That 300 is the base or horizontal side of the rectangle. Okay. Come this side. Then radius 115. So I wrote diameter 230. And I shown there, see. And one more thing, if it is 140 here, here also 140. I want every dimension. These are radius. See here, diameter 230 or radius 115 means 115 and this also is 115. I forgot to enter, I will enter now. This also is 95, come this side. 95, you come this side. Okay. This also 115, if not clearly visible, I will make neatly 115. Okay. This clear, This clear. Then when this is 115, this is 140, from here to here, see, in case you want it, from here to here, if you want it, from 300, subtract 115, you will get 185. The pen fell down because it is maybe thinking, why is explaining such a small thing which anybody can understand? But I always explain, okay, this is also over. Then the dots are actually not decimal actually to show it is already over. Okay, 115 over. See, this 60 gap is given. 60 gap is given. Then they told this is radius 95. So I wrote diameter 190, double the radius. Okay. Therefore, from here to here, diameter is 190. I wrote there, and radius from here to here, see, is 95. From here to here is 95. That also clear. Now, see, extreme left here. Extreme left is here. Extreme bottom here. So, from this point, see, from this point, that 95 is troubling me. I will do one thing now. That 95, I will write somewhere else. Okay, where I will write, anywhere you can write. Actually not required. Anywhere you can write the 95. I will write here. No, here there is no space there. Okay, okay. No problem. Here I will write. 115 is difficult. 115 I will write here, so that the complication is not there. 115, okay, and then see, this is 95. Where I will write? Here I will write. 95 below. Okay, no problem. Now, see here. This is the extreme left and extreme bottom edge. See here, extreme bottom. This I will take O, origin, for locating centroid, or I will take X this way, sufficient, and Y this way. This all explained for you. Or you can do one thing, if you want later for checking purpose. See, here you can take, here, Aterco. This is Abelco. Okay. Now not required, one sufficient. Now, correctly number. Number 1, I will take right here. 1 is, see, 1 is the rectangle. See, actually, here, from the rectangle, a circle is removed. So what you will do is, ignore the circle. Take full rectangle. That is 1. You can make a note here. 1 is a rectangle. And 2 is circular area removed or cut out from rectangle. Therefore, now only remember, when you find area A1 minus A2, then continue. X bar A1 X1 minus A2 X2, then continue. Y bar A1 Y1 minus A2 Y2, then continue. Okay, this already told. Now everything is clear? Okay. Now we want the full boundary dimension. See, 140 plus 185 plus 115 plus 95 will give 535. Actually not that way. 140 plus 300 plus 95 will give you 535. Let me check it. Suppose later by chance it is a wrong problem. 140 plus 95 plus 300 is 535, correct. And the full height is 150 plus this 250 plus, see, 250 plus this 115 plus 115 is 515. 515. Oh, I see. 515. Yes, correct. I wrote up to here only. Full means it is up to here. See, extreme bottom. One minute. Correct. See, I'll do one thing. 115. I'll write here. 115. 185. I'll write here. 140. I will write here, so that I can extend that line. See, the bottom extreme end. Extreme bottom. See. Up to here. The total is how much I told? Just now. 550. Okay. 550. I should check now. I don't think space problem is there. I will write in between. 515 is the overall dimension. Here, 535. This also I do same thing. I write here. 535 is the overall length. So, full from extreme right to extreme depth is 535. Top extreme to bottommost extreme is 515. Okay, now here there is space for marking x bar, y bar I will mark here. Okay, there is no problem. Now go for first usual story all you have to write. Only this question I will write because it's a master question. Little more statement I will write for this question. And I will give all the explanation for this question. See, okay, now you should write it. I am dictating only. Then what all I tell you, write. See, required to find moment of inertia, that is I, about centroidal axis, that is understood. When it is simply given centroidal axis, it is understood that it is about centroidal horizontal axis, that is called xx. You should write it. And vertical centroidal axis, that is yy, means they want to find I about xx and I about yy. Both this xx, yy will pass through centroid G for the entire area. Therefore, you have to first locate G. At that time, take reference O origin. I remember it is Abelco origin. Consider reference axis OX to right of O and OY to upper side of O. Okay, then x bar, horizontal distance of centroid from, see, horizontal distance is from y-axis, from OY axis to which side? To right side, equal to A1x1 minus, be careful, this 2 is removed. To give a warning for you, I will double round, see, I will shine it. Remember, you tell it, see, you are removed, be careful. You are removed, so be careful. Therefore, minus A2x2 plus A3x3, etc. Total how many are there? 6 are there. Up to A6x6 divided by total area, which is A1 minus A2 plus A3, etc. up to A6. A1 minus A2, this is already known for you. A1 minus A2 plus A3 plus A4 plus A5 A6, A1x1 minus A2x2 plus A3x3 plus A4x4 plus A5x5 plus A6. Same way, right? Y bar up from where? From OY, from OX, from OX equal to, formula is A1Y1 minus, because second part is removed, minus A2Y2 plus A2Y2 plus A3Y3. Now you continue. plus A4Y4 plus A5Y5 plus A6Y6 total divided by area. Area equal to once again A1 minus A2 plus A3. A1, be careful, minus A2 plus A3 plus A4 plus A5 plus A6. Write all the statement. You make this question a perfect fair copy, preferably in a drawing sheet, so that in future, whenever you get a semicircle or a quadrant, see, one semicircle is this way from horizontally, vertical height, see, one this way, one this way, one this way. That's why 2 I have taken. So you will have no difficulty in future when you encounter what? Semicircle, circle, semicircle or quadrant, and also everything should be clear when some cutout area is there. Already rectangle and triangle, all triangles, any type of triangle, triangle in general or right angle triangle or what isosceles triangle already over. So by the time this question is over, 100% there is no problem for moment of inertia calculation in future. Just enjoy. I will not waste time every class now, but some will tell you, will explain. One small clarification. Today I got a comment. Somebody wanted to know about principal axis. It is asking for too much now. See, XX and YY for such questions, they are not a principal axis. They are centroidal axis, no doubt. Principal axis are the axis about which moment of inertia is either maximum or minimum. But whenever there is a axis of symmetry is there, see, if the given area is symmetrical about XX axis, then XX is principal. By virtue of XX being principal, YY also qualifies to be principal. Same way, if it is symmetrical about YY, YY is principal. Since YY is principal, it is perpendicular, XX is also principal. So, if either of XX or YY are they are axis of symmetry, then your XX and YY itself are principal axis. About one of the axes, moment of inertia is maximum. About other axis, moment of inertia is least. That is you require. But when you consider bending of unsymmetrical bending, where neutral axis is not this way, or don't worry too much now, unsymmetrical bending, in that case you require principal moment of inertia. Then IXX and IYY are not principal. Principal is something else. Usually in steel table solve, UUVV. Then see, if this is XX, say, if this is XX, this is XX, this is YY, then principal are one of them, say UU, I don't know which is UU, anything, and VV. And this angle also required, theta. Then UUVV are the principal. So then you require product of inertia IXY at that time. Then the formula will be, see, stress equal to P by A plus M dash Y into IXX minus MX into IXY divided by IXIY minus IXY square plus once again for other axis. Don't worry about too much though. But he asked, can you explain all these? No, it is beyond the scope of this one. When in the structural part later, actually not in ordinary, when I upload classes for higher concept, advanced structures, a lot of time is there. When I need this moment of inertia, moment of inertia about principal axis, when there is no symmetry, that time I will tell how to find that I about UU, I about VB. Actually, remember, it is found in the same way as finding principal stresses. If you remember, in two-dimensional stress system, principal stresses are sigma x plus sigma y by 2 plus or minus root of sigma x minus sigma y by 2 whole square plus tau square, and inclination of the principal axis with respect to what plane containing the stress sigma x is tan inverse of 2 tau divided by sigma x minus sigma y, they all comes. So that time I will tell, sorry, whoever has raised that concept, right now not possible. It will be too much beyond the limit. When the time comes, I will tell. See, he told, I can't understand. You study somewhere else or wait till I upload that one. Right now, I cannot go for principal axis. See, in case of angles section, even in steel structures, remember, when you calculate tenderness ratio, you are not using Rxx, Ryy. See, a term called L effective by R will come. L effective by R. This R calculation in case of channel section or I section or some built up section, that R usually you take either R about XX or R about YY, whichever is least, reason is there. But in case of angle sections, that R is RUU or RVV, not RXX and RYY. So there but we are not bothered because in the steel table or handbook, RUU, RVV are given there. They are given. So, but principle is there. In the steel structures, I will explain that one. But calculation of moment of inertia about principal axis, when they are not horizontal and vertical, see, when XX and YY are not principal axis, does not come in this course. Sorry, there is a limitation for me. For one person or few persons requirement, I cannot give trouble to entire student community. So when you study subject, you study systematically. Therefore, I have tell with regret. You are told, if you got a spare time, I don't have spare time also. I am very busy person. Even if spare time is there, I cannot tell here because it is beyond the scope of our study at present. When the time comes, I will explain. So, hope you will understand. Now, I will prepare the table. Now, location of centroid, part number, area, x from OY, y from OX. See, first areas, before starting. Circle area, pi by 4 of diameter square, pi by 4. Semicircle area, half of that one, pi by 8 of diameter square. Quadrant of a circle, half of semicircle, pi by 16 of diameter square. Okay, so I won't waste time now. Figure number 1 is a rectangle. 300 by 250. Okay, full. Figure 2, pi by 4 of 80 square. Figure 3, pi by 16, pi by 8 is a semicircle. This is pi by 4 of 80 square here. Pi by 8 of 190 square. Pi by 8 of 300 square. Pi by 16 of 280 square. Pi by 16 of 230 square. But remember, this is remote area, warning. 1 minute, if the camera is okay? Because sometimes when I shift the camera to one side, left side is a problem. Okay, slightly I have to move this side, very slightly. Okay, no problem. Okay. Slightly I have to move. Okay, no problem. You can make out. 1, 2, 3, 4, 5. Okay, so 2 is warning, remote area. This I told earlier long so many times. Okay, now x distance. See, once I finish x bar, y bar, before I start moment of inertia, for all the components, I will explain centroid and moment of inertia once again. So wait for little time. But you already know it. See, G1, centroid of rectangle. This is 300, 300 by 2, 300 by 2. This is 250, 250 by 2, 250 by 2. 2, circle, centroid is exactly center. 3. See, semicircle, remember, semicircle, see, centroid is this, see, this is axis of symmetry, you know it. This is axis of symmetry. When there is axis of symmetry, centroid lies in the axis. So, it is this way 190 by 2, 190 by 2. But this way, see, from here, base, not from here, 2 times diameter divided by 3 times pi. Come here, 4. This is axis of symmetry. So, centroid lies here, G4. This way, 300 by 2, 300 by 2. But this way, 2 times diameter, 300, divided by 3 pi. Then 5 and 6, they are quadrants. Quadrant, there is no symmetry. See, centroid will be always near to this point. This is smaller, this is bigger. This is smaller, it's out of scale. It should have been shifted upwards. Okay. What is there? Okay, G5. Slightly. Oh, no problem. Such things you will not bother. Okay. Green color. Okay, no problem. So it's again coming, not green, red color is coming. Okay, green color. See, this is 2d by 3 pi. This is 2d by 3 pi. See, this is actually around 2d by 3 pi is, with respect to this radius, it is 2 divided by 3 divided by pi. 0.2 of diameter. So divided by 0.5 is 42% diameter by 2. See, this is around 42%. This is 42, how much percent? 42.4%. 42.4%. Other is 57.6%. Like not 1/3, 2/3. See, lesser, higher, lesser, higher. Because see, more area is here. See, this way, downside more area. So closer to bottom. This way, closer to here, like right angle triangle. See, where center is there, from center, when you go to G, these are 2d by 3 pi. Here, see, from center when you go here, these two are 2d by 3 pi. From here, you have to subtract. So, 2d by 3 pi, 2d by 3 pi, d is 280. This also, 2d by 3 pi, 2d by 3 pi, diameter is 230. This much information. First of all, location of centroid already over. The big questions are over. One big master question was there. Okay, start now. X, see, this way. G1, see, 95 plus half of 300. G2, 95 once again plus half of 300. Sorry, 2 is here, not that is 4. Okay. I thought this is 2. G1 over G2, see, 95 plus 25 plus half of 80. Diameter is 80, half of 80. See, I wrote this distance if you require it. Suppose you require, this is 25. How much is this distance? From 300, subtract 25, subtract 80, you get this distance. Suppose you want this distance, it is from 250, subtract 35, subtract 80. If you want it, I think you don't require, I think most probably. Okay, you'll see later. Then G2 over G3 here, see. From here to here, see, this is 2d by 3 pi. So, 95 minus 2d by 3 pi. Diameter is 190. G4, 95 plus exact center, this way center, half of 300. G5, 95 plus full 300 plus 2d by 3 pi. G6, 95 plus 2d by 3 pi. Correct? correctly. Okay. Get all the areas. Remember, total area is A1 you better write everything there. A1 warning minus A2 plus A3 plus A4 plus A5 plus A6 will give you this area. X bar equal to A1 X1, be careful, minus A2 X2. You should write, see, not waves here. Wave means you show the calculation. A1 X1 minus A2 X2 plus A3 X3, A4 X4, A5 X5, A6 X6. You get X bar. Y bar. 1. From bottommost. 115 plus half of 250. 2. You see, now useful now. 115 plus 135 plus half of 80. Or by chance, if this 135 is not written, then 115 plus 250 minus 35 minus half of 80. Both are okay. 3. Here. 115, don't see this one now. It's required now. See, 115 from here, then plus 60. Where is it? See, 115 plus 60 from here to here is half of 190. Or 115 plus 250, 115 plus 250 minus half of 190. Both are okay, your choice. G4, 115 plus 250 plus 2d by 3 pi. Diameter is 300. I wrote there 2d by 3 pi. Which one? That is for fourth one. Here. 5. From here. 115 plus 2d by 3 pi. This one. From here to here. See. 115 minus 2d by 3 pi. Then write y bar equal to A1 y1. Be careful. Minus A2 y2 plus A3 y3 plus A4 y4 etc. etc. Get it? 267.720 millimeter. I cross-checked it by finding X bar from that side and Y bar from top. Perfectly matching. See, now therefore see, when I found X bar from that side, I wrote there 290.675. When I do from, you don't do it, don't waste time. This all we have done earlier. Suppose I took origin here, see, right side topmost edge here. This way X, this way Y. Then I got X bar 290.675. See here, when this total is 535 minus 244.325, it is coming 290.675. Correct, tallying. That's what. Now nobody can tell. There is not a single dot mistake. And Y bar from top, if you use this one, total is 515. From 515 subtract 267.720, you will get 247.28. Yes, that is what I got. I wrote there. I independently found X bar from this side, Y bar from top, because I do not want any mistake in this problem. Okay, now over. Now we are ready for moment of inertia. So before that one, we will first locate centroid now. See, correctly. From this axis, see, OY axis, X bar, 244.325. See, 95 plus, this is 115. 95 plus 115. 210. Oh, further that side. Up to here. 95, see here. 95 plus 25 is 120, further this side, plus 80, 200. Oh, how 200? 95 plus 25 plus 80. It is not 195, I think. It is not 195, 200. 200 means it is 2, how much is? Okay. This is something else. 25 plus 80 is 19. That's okay. From here I am measuring. Okay. No problem. See, 95 plus 25 is 120 plus 80. 200. Still more. Why? 244. Okay, now come to this centroid. 95 plus half of 300. 300 by 2. 245. Oh, 245. But X bar is 244.325 means slightly this side. See, from centroid of rectangle. This is very, very important. Correct marking. Otherwise, you'll have problem later. See, from centroid of rectangle, very, very slightly, very, very small, but very, very small. If I mark that way, see, I think if a centroid is marked here, I have to mark here. It will touch. So what to do? So therefore, I slightly shift this side. See, slightly this side. Okay. Continue. These are same level. Continue. Jump and continue. It will go beyond this one because why? This is 95 plus 115 is how much? 95 plus 115 is a little out of scale. Okay, no problem. 95 plus 115 is 210. So this is out of scale. This should have come. See how much this one? Okay, no problem. Why bother such things? Come. Jump. High jump. Y axis. From here to here is your X bar equal to 244.325. Then immediately from the right extreme end to here, from total 535, subtract this one and calculate 290.6, 290, okay, it looks like 290.675. Okay. Now, see, from today I decided to talk little slowly. People may tell little slow. You can increase the speed in the YouTube. 1.25 you can go for. But still, learning, listen to me correctly, natural speed. You may tell slowly telling. For your benefit I am telling slowly. Do you want to show how fast I can solve? One day for a demo, one question I will solve very high speed for a demo purpose. I will show my real speed one day, not now. Not boosting actually, I will show it to you. What speed I can tell. Okay. Then people will, in the offline class, sometimes student will tell, rarely, sir, little fast you can tell. Then I will tell, okay, shall I use my full speed? Okay, sir, I will start. Within 2 minutes, little time you will tell, sir, no, sir. You do as you like, sir. Yes, I told. Maybe you understand fast. See, there are others who find difficulty. They are cleanly they have to follow. So, if you understand everything, you relax. You are not losing. Okay, start. Y bar. 267.720. 115 further above. Plus 60. Surely further above. I already marked it there. See, 115 plus 60 is 175. Further above. Okay, now come up to edge of the circle. How much? 115 plus 60. No. 115 plus 135. 250. Oh, still more. So it will go above the edge of bottom edge of circle. Now come to this center, see, G3 level, this midpoint, 115. Oh, there is one small mistake is there. That is one small mistake. Okay. It is not wrong. I did correctly. See, okay. 115 is up to here. Okay, no problem. It is not a mistake. See, make a note. It is up to here. But still, I told, see, correctly when you come here, I told 100, I was showing here 115 plus 60, I told correctly. By mistake, it came up to here. I corrected it. In the comment, I will write. Okay. Actually, not right. Somebody will tell, sir, that is wrong. Sometime, if such thing happens, wait for the class or see the comment session. Okay, now up to here. 100, but see, I never used this one. I always show here. 115 by 230 by 2. 115 plus 135. Already over, more. 115 plus 60 plus half of 190. Actually, that number is there. Why? It is Y3. See here, it is Y3, 270. 115 plus 60 plus half of 190 by 2 is 270. Oh, how much you got? You got 267. So, slightly below this point. So, your x-axis will come. See. It will go this way. It will cut the circle here. Let it cut, no problem. It's slightly above this point. Yes, much above. Why? Up to that point is 115 plus 125. How much it is? 115 plus 125 means 115 plus 125 is 240. It is 244 above. Okay. Now here, it will come here. And here, when you reach here, you should be careful. See, 115 plus 140. 115 plus 140 is 255. Oh yes, above, no problem. It will go above. It will go here, no place here now. See, continue, break it here, take it here. Red color is there. X, see, that's why red color. To avoid confusion, that's why, see, jump here. This is your X, see, don't disturbance. So, from the bottommost edge here, this distance is your Y bar, where I'll write now, here. Y bar equal to 267, see, this point, remember now, by mistake I marked up to here, but while explaining, I was telling this one only, I never touched here. See, such it happens, 267.720. 267.720 is from here to here. I'll do one thing now. See, Y bar, I'll round off to understand. Y bar, to understand, because here no problem, here mixing up will come. Okay, then from the topmost edge, these are disturbing actually, no problem. See, from the topmost edge, from there to here, this will be from total 515, subtract 267.720 is 247.28. Oh, 720 not required, 72, okay. Why? See, third decimal, if 0 came, 247.28, correct. 28 is this distance. Okay, round off that also. This is I am not rounding off. This is your X bar, Y bar, and remember, this is separate in between, or 1 minute now. Why disturbance here? 1 minute. How much you got? This is your highlight here. Okay, this is better. Y bar equal to how much? 267.72. 267.72. I think it is visible. Visible. This is Y bar. 267.72 is fully visible. This is something else. 1 minute. Actually not a problem. Still, somehow, sometimes students should not get confused. 190. Go that side. I will tell the 190. Go that side. Don't disturb. That is this 190. Okay. Now okay. No disturbance, nothing. This is your centroid G for the lamina. First of all, remember, strictly speaking, up to here is already over earlier. Long back when you are doing centroid, this all over. Big questions you are taken. So, our real class will start now. Then what about this 1 hour time they will tell? That is once again I told you. Now get ready for moment of inertia. Okay. I will do one thing now. I will start the preliminary part first. See, this all I can remove? Yes. Everything can be removed. Now, right. So that, start. Right. Calculation of I about xx. Or probably calculation of ixx and iyy. Okay, both I will write. Calculation of ixx and iyy. Before that you write by parallel axis theorem. I'm wasting time. I about any axis equal to, see, it is falling down. Ig plus A into h square. Most important. Okay, this much statement common for both. Now start. I about xx. Now we'll find first ixx. Okay, start. One by one. Space problem is not there. Yes. Ixx for 1. I space any problem? No, okay, no problem. I'll write and then decide. I don't want to rub one thing. Actually, I put a light red line here so that I can make out. I should not go this side. Okay. Now, before I start moment of inertia, 1 minute now. See, you write here. Consider that most powerful term, actually h. See, h is the very powerful term. This is this h is the most important. Red, wait, what happened? Red color. I told you, this h is the most important. And Ig is by formula. Area you know it. Now, anyway, before going to h, first to consider that Ig. So, first make a note that Ig term. See, rectangle, I will not explain. See now, circle. Right here, circle. Diameter D. Center is here. Centroid is here. G. Its G is here. Small g. X axis and y axis. Okay, see now, see here. Area equal to pi d square by 4. You know it. Then, for a circle about any axis, I equal to pi d power 4 by 64. Pi d power 4 by 64. This you should remember in sequence. See, how to remember? Make a note. For a circle, centroid is known. area pi by 4 of diameter square. When you go to semicircle later, half further. When you go to quadrant, area becomes further half. Okay. So now only I will tell semicircle area pi by 8, quadrant pi by 16. Area becomes half, half, half. See, same sequence. But I, for a circle, both are symmetrical. See, both are pi d power 4 by 64. This is circle number. Okay, now, okay, remove. Consider semicircle. Semicircle. See, here, one semicircle is here, this way. This way, one semicircle. There is one more semicircle here. This is your fourth one. See, this is 4. This is your 3. Okay, see, now, for this one, centroid is here, G4. Here, centroid is here, G3. Now, what to remember? Area for semicircle is area. I already told you, half of circle, A equal to pi by 8 diameter square. We are differing with respect to diameter. See, I told you diameter you are doing. Okay, over. I, see now, correctly. This is one of the centroidal axis. This is other axis. This is one of the centroidal axis. This is other axis. Now, this distance is 2d by 3 pi. This way is 2d by 3 pi. This way midpoint here. This is 2d by 3 pi. This all told for you. 2d by 3 pi. This way midpoint. Now, when you want I about this axis, I about IG. See, this IG when you want this IG, I told you something long back, very clear. You have to go through that summary part all. Symmetry is there means half of circle. If symmetry is there, whatever is I for circle, it's half. If symmetry is not there, see, what is it? If symmetry is there, this is the last time I will tell there, then your IG is half of that for circle. That is half of pi d power 4 by 64 or simply pi d power 4 by 128. Remember, here pi comes. Remember, over. If symmetry is there. If symmetry is not there, then pi will not come. See, actually I should not tell this way. I am telling correct concept. If symmetry is not there, then also it is d power 4 only. But no pi. Instead, a decimal number. The decimal for a semicircle is 0.006. I will derive it. I am going to derive it now. Pi by 128 minus, oh no, calculator is not on. Okay. Pi by 128 minus pi by 8 into 2 square divided by 9 divided by shift pi square. I have some problem. Pi by 128 minus bracket 2 divided by 3 divided by shift pi close square into pi by 8. 0.00686. See, I can derive it. It is 0.00686. So, remember now, if symmetry is there, IG for semicircle is half of circle. Circle how much? Circle is pi by 64. It's half. Pi by 128. Then pi will come. If symmetry is not there, then pi will come actually, but the pi is already, you see, when I derived just now, I used pi. That all will finally come to a number. If symmetry is not there, then also it is a diameter power 4 only. See, for circle or semicircle or quadrant, diameter power 4 only, but the decimal number is 0.00686. Pi is not there. Okay, now, therefore, right here, see, this axis, symmetry is there. See, this is symmetrical axis. So, answer is pi by 64, 120. Pi by 64 for circle. Pi by 1, half. If symmetry is there, half that of for circle, but pi is there. Pi by 128 d power 4. But this axis, see, symmetry is not there. See, these are different distances. Then 0.00686 d power 4. So here, for this figure number 4, about horizontal centroidal axis, decimal with d power 4. About vertical centroidal axis, same as circle format, but instead of 64, 128. But here, when you go to figure number 3, see, this is symmetry axis. See, this is symmetry. So, this I is half of circle, this Ig is pi by 128 of d power 4. But this axis is not symmetrical. Therefore, here, this Ig equal to 0.00686 d power 4. So, when you go to this semicircle, about horizontal centroidal axis, pi by 128 d power 4, when you are going for vertical centroidal axis, see, symmetry, pi by 128 d power 4, but when you go for horizontal centroidal axis, it is decimal 0.00686 d power 4. But this semicircle, when you go to horizontal centroidal axis, symmetrical, pi by 128 d power 4, but when you go to vertical centroidal axis, symmetry is not there. See, these two are different. 0.00686 d power 4. Okay, this is also over. Now, lastly, quadrant. This is simple, I tell, quadrant. Quadrant of a circle. See, let it be any one quadrant. See, one quadrant is figure number 5. Other quadrant is figure number 6. Figure number 5 is like this. See, this way. Figure number 6 is like this. Okay. Okay, this way. This is G. Actually, it has gone much more. Hey, come down. Don't go that much. Okay. Here, see. This is figure number 5. This is your G5. This is your G6. Remember, area. When you want area, pi by 4 for circle, pi by 8 for semicircle, pi by 16 for quadrant of diameter square. Okay. Then, there is one centroidal axis here. See, one more axis here. One centroidal axis here. One more centroidal axis here. Quadrant, symmetry word is not there. First of all, there is, see, semicircle, circle, both are symmetrical. Semicircle, one symmetry. Quadrant, the word symmetry does not exist. So, symmetry does not exist means only decimal. What decimal? Whatever is the decimal for semicircle, it's half. So, 0.00343. I told earlier 0.00686. Its half is 343 d power 4. That is this Ig and also this Ig. And here also same is this Ig and also this Ig. For a quadrant, I about any centroidal axis, because both symmetry is not there. So decimal number pi will not come. 0.00686 for semicircle, it's half. 0.00343 d power 4. That's all. Now onward, actually, this already I told earlier in summary, see, not this way. But today very slowly I am talking. Okay, now, that's all. I will start moment of inertia. If anybody still find difficulty, better you go for a person who teaches much, much better than me and explains much, much better way or more detailed than me. And for this question, you should take 10 hours then. Okay, I'll continue. Okay. Now, what all I explained just now regarding that IG, thoroughly understand, again go through. Now I won't waste time. Start. Ixx you have to calculate. See, parallax theorem is there. Ixx power 1, 2, 3, 4, 5, 6. 6 parts are there. Start one by one. Come to one. Every class I cannot tell. First come to centroid. Consider axis passing through centroid parallel to xx. See, this axis. Write I about that axis. 300 into 250 cube by 12. This I cannot explain. Plus area. 300 into 250 is the area into from centroid G1 to xx. See, moment of inertia about horizontal axis means BD cube means vertical cube, and also remember I about horizontal axis means vertical distance. This or perpendicular distance from centroid to xx is this distance square. See, look this side. 267.72. See, this I am writing in front of you. 267.72. From here to extreme bottom, subtract 115. Minus 115. So 267 point that one minus 115 minus this midpoint 250 by 2 minus 250 by 2 whole square. Okay. Calculate whatever comes right there. Answer. Next. I won't calculate. This question answer is not important. Steps are more important. Come to 2. Where is 2? Circle. 1 made. See, 2 is danger. Removed. Even if it is removed, theorem is Ig, not Ig minus A square. Theorem is Ig plus A square. But lastly what you do is, when you do final answer, see, 2 is danger, Ixx power 1 minus Ixx power 2. There you account it. Don't use minus sign here. Ig minus A square. Then you have to write minus Ig minus A square. Then you have to plus it. Don't do those things. You do by usual parallax theorem. Removed, cut out, you consider when you find the final answer. The same as your x bar, y bar. Okay, start. First, I about its own centroidal axis parallel to x axis. Circle. So y vary. Pi by 64 of diameter power 4 plus area. Pi by 4 diameter square into from centroid of the circle, see, to this axis, see, this distance square. See here, from G2 to xx, this distance square is 247.28. See, from here to here you want 247.28 minus 150 minus 35 minus half of 80. 247.28 minus 150 minus 35 also minus half of 80 whole square. See, this distance square. It should be crystal clear now. Those who are attending my class from beginning and studying, they will tell so easy. Okay, easy, correct, but right. 3. First about, see, its own centroidal. Oh, this is symmetrical. See, for a semicircle, this is symmetry. Therefore, half of circle. Pi by 128 of already just now explained. 190 power 4 plus pi by 8 of 190 square area into from centroid to xx. See, this distance square is 247.28 minus 150 minus from here to here is, this is how much? This is exactly 190. If it is 190, center here, half of 190 minus 190 by 2. You should write actually horizontally. Here space is not there. So actually I should have written, if I want to write everything horizontally, I should put a smaller sketch then. It won't be clear. Okay, square. Okay, fourth one. See, I about its own centroidal axis. Parallel x-axis. Oh, this is not symmetrical. See, that side is separate. This, oh, then if symmetry is not there, semicircle, it is pi is not there, decimal number 0.006860 into diameter power 4 plus area is pi by 8 of 300 square into from centroid to x-axis. See, now careful, this, see correctly. This distance square, be careful, this is h square, h for fourth part, very careful, you write pencil. Now little careful, see. From here to extreme fiber is 247 point, how much? 28. 247.28 subtract how much? 150 minus 150. What it will give you? See, 247.28 minus 150 will give you from here up to here. See, it will give you this distance. Then plus this distance is 2d by 3 pi plus now 2 into diameter, diameter 300 divided by 3 pi, that number to be squared. Okay, see, we want this distance square is this full distance, whatever you got, subtract 150, you will get this distance from this distance plus this distance, 2d by 3 pi over. Come to fifth one. First, I about its own centroidal axis. It is quadrant. For quadrant, symmetry word is not there. So decimal, what decimal? Semicircular decimal half, 0.00343 into diameter power 4, area pi by 16 diameter square into from centroid to x-axis, from here to here. See, from here to here. This distance square is 267.72. That is from here up to extreme bottom. Subtract how much? 115 minus 115 will give you, see, 267.72 minus 115 will give you this here. See, will give you, see, 267 point something minus 115 will give you this distance. Again minus this distance, 2d by 3 pi. Minus 2 into diameter is 280. Diameter is 280 divided by 3 pi, that whole square. Okay. This one, I about its own centroidal axis, green color. Its own centroidal axis. See. Once again I told decimal 0.00343 diameter power 4, 230 diameter plus area into from centroid, see, from centroid to axis, see, from here to here, this distance square is 267.72. You should be very careful. See, 267.72 minus 150, subtract 150. What it will give you? 267.6, how much? What is the number there? 72. 267.72 minus 115 will give you this distance. But we want from here. So whatever you got this distance just now, plus this distance, plus 2 into diameter, very diameter, 230. 2 into 230 divided by 3 pi, that number to be squared. Not into 2, some will tell into 2, no. that is to be squared over. Find all of them, and remember, warning, 2 is cutout area. So final Ixx for entire area is Ixx power 1 minus whatever you got, Ixx power 2, then plus remaining. Get the answer. Okay, now Iyy. We'll write first. Now lastly, Iyy. First of all, someone will tell, sir, you are see, excuse me, you are telling how many times vertical axis you want. So perpendicular distance will be horizontal. See, same thing. People will do, so if anybody is non-technical, if he is in the classroom, he will tell, after the class he will tell, sir, how many times you are telling? Why? I counted it. This is, you are telling maybe 100 times or 200 times. Okay, what moment of a force also you told that way. Vertical force means horizontal distance. Horizontal force means vertical distance. Vertical axis means horizontal distance. So, and horizontal axis means vertical distance. Now you want vertical axis. So, this way distance. Okay, start. For 1, I changed everything. First, see correctly what I am doing. I want now green color, okay. See here, I about its own centroidal axis. Parallel side, 250 into 300 cube by 12 plus area into from centroid to YY, a very small distance square, whatever is there, this distance is 290.675. 290.675, very small distance it is. See, we want this distance. 290.675 minus 140 minus 300 by 2. Minus 140 minus 300 by 2. If anybody, if this is not clear, from tomorrow, do not attend my class. If this is not clear. Someone will tell, sir, quadrant semicircle clear. Sir, rectangle not clear. What is this? Sir, I know how to drive a truck or how to drive a car. I do not know how to drive an auto rickshaw. Okay. Then, start. I about YY. Where is YY? For 2. Where is 2? A circle. See. I about its own centroidal axis. So, this distance we used only once actually. This axis, okay, that circle. So pi by danger, pi by 64 of diameter power 4 plus area into, see, from centroid here, this distance square is 244.325. See, we want this distance, 244.325 minus 95, not over, minus 95, minus 25, again minus half of 80. 80 by 2 whole square. See, this distance minus, we want this, we want which one? This distance minus this distance minus this distance minus half of the diameter. Okay, over. 3. Where is 3 here? First, see, this is 3. First, I about, see, its own centroid. Oh, this is not symmetrical. Last time it was this way, symmetrical. If it is not symmetrical, point not semicircle, 0.00686 diameter power 4 plus area into, see, from centroid to here, this distance square, be very careful now, this distance square is 244.325, very careful, 325 minus 95. What this will give you? See here, 244.325 minus 95 will give you from here to here. This distance, but we want from here. So whatever you got just now plus this distance, that is 2d by 3 pi plus 2 into diameter, where is diameter 190 by 3 pi whole square. Okay, start. Fourth one, here see, I about y axis. First about its own centroidal axis here. Oh, this is symmetrical. Why? Semicircle, see, both are symmetrical. Oh, symmetrical means pi by 128 diameter power 4 plus area into, see, this distance square. That distance square is, look this side, 290.675, 675. See, we want this distance, 290.675 minus 140, see, 290.675 minus 140 minus this distance exactly half of 300 by center minus 300 by 2 thousands of time told whole square. Then fifth one here, I about, see, its own centroidal axis, green color, okay, green color, its own centroidal axis, this axis. So quadrant, so decimal, 0.00343 diameter power 4 plus area into from centroid here to y axis, see, this distance square, that is 290.675, see, you should be careful, 290.675 minus 140, 290.675 minus 140 will give you from a axis y up to here, then plus this distance, plus 2 into diameter 280 divided by 3 pi whole square over. Lastly, sixth one, start. I about its own centroidal axis. Sorry, green color, okay, its own centroidal axis. Once again, decimal, 0.0, this all explained, 0.00343 diameter power 4 plus area into from centroid to here, see, this distance square, that distance is 244.325, that is this distance minus how much? Minus 95 will give you from here up to here. Then again minus this distance, minus 2 into diameter 230 divided by 3 pi whole square. See, when you have to add, when you have to subtract, you should be careful. See here, this distance minus this distance will give this distance plus this distance here. This distance minus this one minus this one. Observation you have to do it over. Calculate. Finally, IYY for entire area equal to IYY for 1, whatever you got here, minus, be careful, IYY for 2, then keep on adding the remaining, get IYY, get the answer, share the value with your friend circle who are equally serious like you, and get the comment from them in your WhatsApp. Yes, your answer is correct, I also got same answer. Otherwise, but actually what to do is, without seeing what I wrote, you write this in a drawing sheet, systematically write, take your time, once in a lifetime, write everything, calculate, then compare with the answer you get here, or you compare your steps. See, you might have got this distance by some other way, no problem, but whatever you get, see what number I will get here, same number you have to get it. Sometimes people may look other side. When you do Ig plus A square, check your Ig, check your area and H distance. Final answer, no problem. Okay, now that's all. Once again, it's a master question covering circle, semicircle and quadrant, and also see one semicircle this way, one semicircle this way, one quadrant that way, one quadrant this way. And also the concept of something removed, that also covered. Strictly speaking, I can close the class here. Moment of inertia I can close. Now only any question you are getting will be simple, but no, I will continue for at least 10 more classes, 10, 12 classes. Surely more, because yes, if I do only tough questions, very tough questions, easy questions, see, sometimes what happens is, people get difficulty. Such easy one rectangle, one semicircle, they make mistake. So this all I will do one by one. But at that time, what all concept I told today, that I will not repeat this much. Briefly I will tell. Again I will give warning in between. Difficulty means go to master question. Study and come back. Then only you will learn. It is a condition for my class. My class is not like classes people upload randomly. Today they will upload reaction calculation for a cantilever beam. Okay, tomorrow they will upload bending stress question for a beam. Then suddenly a diffraction question. No background, no information, simply telling. That is their problem, not my. This is a course, systematic course for engineering mechanics now. Once we complete, see, moment of inertia is okay. Now we are coming to near the end. Then friction I will not do too much of question, because structural engineering point of view, limited knowledge required, but still my course is for everybody. Therefore, I will do sufficient question, maybe some 20-25 classes. I will take that much. I will do plenty of exercise I will give you. Once friction is over, see, kinematics or that what I call that kinetics or projectiles all, that I am not covering. That is not in my course. Somebody may require you study it. Structure engineering not required. The moment I finish friction, I will change over to the most powerful, number one, strength of materials. Entire structural engineering stands on not only strength of materials, also on engineering mechanics, but more weightage for strength of materials, because here we consider external effect, there you consider internal effect. Engineering mechanics is like when you look at a person, you tell, oh, he is very healthy person. Strength of materials is not that way. You tell, hey, he got a problem. See, he don't know. He looks that way, but he got a problem. He can't walk. See, he got so many problems that way. Internal problem. Because why? Strength comes there. Mechanics means just physical part. Okay, leave it. We'll continue next class. Thank you.